Okay, so for problem 10.4, example 10.4, we're going to start looking at a yo-yo, and it's asking us to consider a yo-yo of a solid disk with radiuses r and masses m, and um, and it's telling us that we used energy considerations to find the yo-yo speed after it had dropped a certain distance in another previous problem, and now it's telling us to find the acceleration of the yo-yo and the tension in the string. So now it's telling us to find the tension and the acceleration. Now, they didn't really just give us values, so what we're gonna really be finding is like an expression of the acceleration and the tension. So something to know, this is where I made a coordinate plane here. This symbolizes the x direction, this is the y direction, and this is like the yo-yo. We know that the yo-yo is gonna be acted upon a weight force here, the mg. We have the radius here, and the tension of the string is gonna be the tension force. It's gonna be going up here like that. Now, to find the acceleration, we need to derive it from a lot of different expressions and stuff. So to help us do that, we need to use a lot of different things. So the sum of the forces in the y direction, which is where the force is going to be in the tension, right, is going to be equal to the weight force minus the tension force, right? So we know we want to find the tension force, so we'll definitely be using this later on. But anyway, that is equal to the mass times the acceleration, and we're definitely going to be using this later on to find the acceleration in the y direction, right? Okay, so now we're talking about torque. So now the sum of the torque is going to equal torque times the radius, and that's going to be equal to the moment of inertia times alpha, and that is going to be equal to half of m times r squared times alpha, and that's going to be equal to half m times r squared equals, this is still going to be alpha. Now this is the same thing as this one, but we replace the alpha with this, with the acceleration in the y direction divided by r. Where do we get this from? It's from this expression. Acceleration is going to equal to the radius times alpha. So we just solve for the alpha, and then it's going to give us a over r, right? That's what's going on here. And now that we have a over r, one of the r's cancels out, so now we're left with just one r, right? So now we move on. So the r is canceled out, so t it's going to be canceled out now. The torque times r is equal to half of mr, and this is the acceleration, which we know it canceled out. It's no longer over an r, and this radius is going to be canceled out by this radius here on the other side. So now we're just left with the torque is equal to half times the acceleration times the mass times the acceleration, right? And now this is the torque, right? This is the torque. So now we can substitute the torque with this expression here, right? And we knew from before that, hold on, I'm trying to find it right here. We knew that from before that the forces in the sum of the forces of the y direction is going to be mg. It's going to be the weight force minus the tension, right? I think that might be torque. Yeah, minus the torque, my bad. Minus the torque, right? So we have mg minus the t torque, which is right here, which is going to be this right here. We just substituted it. And this is going to be equal to this is going to be equal to this is going to be equal to ma times the acceleration, right? Probably because it says it here. Yes, see, it says it right here that m times the acceleration is going to be equal to that. So we know those things. So when this happens, the m's cancel out from both sides here, and now we're left with g is equal to 3 over 2 times the acceleration. We solve for a, for the acceleration, and we get acceleration is equal in the y direction is equal to 2/3 of the gram, 2/3 of the mass, or grams, right? 2/3 grams, 2/3 of the mass, basically. Sorry, 2/3 of gravity. My bad. So that's very interesting. So that's the acceleration. And here, to find the tension, tension is going to be equal, as we know before, tension is going to be equal half times the mass times the acceleration, which we know is this for here over here. So then we substitute that, we simplify the 2/3 and 1/2, and we get tension is equal to 1/3 times the weight force. So that's very interesting. Yeah, and that's how you do that. So this is acceleration, this is tension.